All right, the first example that we'll do for adding these rational expressions, um, let's just do this. 4 over x, then let's subtract x plus 1 divided by x plus 5. 4 over x minus x plus 1 over x plus 5. So again, we can't just go about combining these two fractions because these denominators are not the same. So to make them common, it's really not a difficult process. I'll just start to write out our solution over here. The common denominator. All you're going to have to do is combine these denominators. You're just going to write it out on the bottom here. You don't actually have to do the multiplication for the denominators. We'll just write it out as x times x plus 5. Then we're subtracting this other fraction, and its denominator is going to end up being the same thing. X times x plus 5. Okay? Fantastic. So hey, this first fraction, like what I need to multiply it by is like what it's missing. It's already got the x, but it's missing the x plus 5. So I'm going to multiply this first fraction by x plus 5. Okay? Now, the second fraction, it's already got x plus 5. What it's missing is just this x. We just need to multiply this fraction by x. So the easiest way to really think about this, well, we're just going to distribute. I'm doing 4 times x plus 5. 4 times x is 4x. And then I'll do 4 times 5, which is 20. Same idea over here. I've got x plus 1 times x. I can just distribute. X times x is x squared. And 1 times x is just going to give me x. Okay, making great progress on this problem. We've got the denominators the same. We've already found the new numerators. All we have to do next is combine like terms. And when combining like terms, you're really just looking for the largest exponent first. The largest exponent up here. The value with the variable with the largest exponent. The x squared. And this might get a little bit tricky when you're subtracting. No x squareds over here, but I am subtracting this x squared. So my result is going to be negative x squared. All right. Hey, the next thing that we need to look for is any variable that just is to the first degree, the x's. Should be pretty easy to combine these ones. I have 4 x's here, and I'm subtracting 1 x here to give me 3 x's. The next term that we'll look for will not have a variable, the constants. And you look for anything that does not have a variable. And the only value we have is the 20. 20 minus, there's nothing here, so it's just going to stay as 20. And again, for the denominator, you don't have to worry about factoring it. You don't have to worry about multiplying out the denominator. It's better to have it written as just factors like this. So I'll just rewrite that, x times x plus 5, and we are done. Fantastic. Everybody think any questions on that first problem at all? Like loads? Pretty confusing stuff. Not so bad. The key really is just multiplying, though. Start with multiplying your fractions. What did I need to multiply this by? It was x plus 5. You need to multiply this fraction by the x. So let's just try another problem. Numerotres, I think is what it's called. Number 2. Hop right into another one. Just keep up the pace. It's good for you. Let's switch it up. Keep it fun. Instead of x, let's do m minus 9 divided by 9m plus 3. And let's add this time instead of subtracting. 4 over 7m squared. Cool. So once again, right? I mean, we're going to end up having to multiply these fractions by something. These denominators are not the same, but we can make them the same. The easiest way to make these rational expressions the same is multiply by their denominators. So this first fraction, as an example, what are we going to multiply it by? What does this fraction need to get multiplied by? 7m squared, absolutely. The denominator is going to be easy for us because we can just write it out as a factor. You could literally just write this one out as 7m squared times 9m plus 3. This denominator is going to end up looking the same. It's already got the 7m squared. We need to multiply this fraction by 9m plus 3. All right. Why did I put plus 9m plus 3? I have no idea why I did that. It should be getting multiplied, right? So hey, let's start the multiplication process. Once again, our first fraction here. This first fraction, right? It's already got the 9m plus 3. Once again, this fraction needs to get multiplied by this denominator. So maybe just to keep track, we'll put up here 7m squared. Then, of course, this fraction needs to get multiplied by. It's already got 7m squared. It needs to be 9m plus 3. Hey, when you get here, don't forget everything here is getting multiplied by 7m squared. So what we're going to do is distribute it. 7m squared times m. 7m squared times m is going to be 7m cubed. I also need to do 7m times negative 9. It's really going to test my multiplication facts. 7 times negative 9, it will be negative 63, and we still have that m squared. All right, all done with the first fraction. Now let's multiply this out. So we'll distribute this way maybe. 4 times 9m will be 36m. And 4 times 3. 4 times 3 will be positive 12. Okay, really close to being done with this problem now. hey, whenever you get your new fractions built with their common denominators, all we need to do is combine like terms. When you do so, just look for the largest exponent first. What term has the highest degree? 3. Largest exponent that we have up here. And then, hey, is there anything to combine with that? There's no other term here to the third degree. So 7m cubed. Next largest term would be the square. Negative 63m squared. Nothing up here to combine it with. So negative 63m squared. 36m, anything to combine it with? On the top here, absolutely not. Finally, we get to positive 12. Nothing combined there either. Hey, don't forget about your denominator. Once again, the denominator you do not have to multiply out. Much easier to work with, written out as factors. We could even factor this, but let's not do that. Okay. Confidence level. Is it increasing, decreasing? Getting better? All right. Hey, I'm going to give you another problem. Number 3. Number 3. Negative 5x divided by 8x plus 7. Let's subtract 6x cubed divided by 3x plus 1. So I think I'll give you a couple minutes to try this one on your own first. The key here is, again, just setting up these new fractions. Find the common denominator, multiply the fractions out, and then combine like terms. It's really the process. All right, hopefully that was enough time to try this one by yourselves. Kind of got the solution going a little bit. Hopefully you know that this first fraction needs to get multiplied by 3x plus 1. The second fraction needs to get multiplied by 8x plus 7. That means our common denominator is just these two things put together. 3x plus 1 times 8x plus 7. Same thing for this fraction. Don't go about multiplying that denominator out. Not a big deal. For this process up here to get to new numerators, we are going to have to multiply these just by distribution. Hopefully we're getting pretty good at this. Negative 5 times 3x. Well, negative 5 times 3 is negative 15. And then we have the x times x for x squared. Okay, and then I also have to distribute to this other term. So I'll do negative 5 times positive 1 to get negative 5x. Fantastic. I screwed up yet? I don't think so. This piece would be same process, just different terms, different values. 6x cubed times 8x is going to give you 48x to the power of 4. Remember, when you're multiplying variables, you end up adding their exponents. And then the last thing that I have to distribute is to the 7. So I will get 6 times 7 for 42. And I also still have that x cubed. Okay, almost done with the problem. We've got the new fractions with their common denominators written out, figured out the new numerators. The last step would be combining like terms. Scan the numerators for the largest exponent, which is going to be this guy right here, negative 48 x to the power of 4. That's what we'll put first. Do we have a cubed? We do. Again, be careful when it's a subtraction problem. Remember, we are actually subtracting this term. So it won't be 42x cubed. It's actually going to be minus 42. Minus 42x cubed. Maybe one of the trickiest things about this, or these types of problems. Keep going down the line. The next largest exponent is our square. Nothing to combine it with, and it was negative. So negative 15 x squared. And we also had that negative 5x. Nothing to combine with it. Then we just don't want to forget about our common denominator. So we'll rewrite it, 3x plus 1 times 8x plus 7. Fantastic. That's adding and subtracting rational expressions in a nutshell or something.